Hello, I want to welcome you to class today. Today we'll be talking about solubility, and this is a very important topic for every one of you that will be writing the JAMB exam. This is a topic you need to understand. So very quickly, what is solubility? Solubility is a combination of two words, soluble and ability. So solubility is the ability of a substance to dissolve in another substance. All right, and that solid substance that dissolves is called the solute, and it dissolves in the solvent, and then a solution is formed. So for example, your table salt, which is sodium chloride, if you mix it with water, all right, you have the salt solution. So the solute is the salt, water is the solvent, and the mixture of the two is the solution. But today we'll be talking about the calculation aspect of solubility, and we'll be looking at three ways by which you could answer questions on solubility. One of the ways you can define solubility is the amount of the solute in moles present in 1 dm cube of solution. Number two, the amount of solute in grams present in 1 dm cube of solution, or that will dissolve in 1 dm cube of a solvent, and this is the unit is grams per dm cube. So this is the solubility of a substance in gram per dm cube. So the question can ask you to calculate in grams per dm cube. The question can ask you to calculate in mole per dm cube. And there's a third one, which is the amount of solute in grams present in 1000 grams of solution. And this is your calculation in gram per 1000 grams. So, having understood this, let us try to look at what are the formulas. So I'm going to use this to derive a formula for you, which you would use to calculate your solubility. The first formula is this. Now if you look at your stoichiometry, you remember that number of moles is equals to mass over molar mass. Also, if you look at one of other formula for stoichiometry, number two, you have number of moles equals molar concentration times volume in dm. So this volume must be in dm. This molar concentration is in mole per dm. So the formula for solubility is actually derived from the combination of these two. So you can say solubility is also the same thing as the molar concentration or the mass concentration of a substance. Alright, so from here, if I want to summarize this formula, I have N equals CV. My number N is number of moles, C is the molar concentration, which is the same thing as the solubility, and I have volume in dm. So if I combine my equation 1 and 2, I would have the formula for solubility. Equation 1 says N equals, so this is the same as N equals mass over molar mass, and my N is also CV. So now this second formula is summarized as N equals CV, and then I can make C the subject of formula. C will be what? Number of moles over volume. That is my solubility. Solubility is number of moles divided by volume. So by C, which is my concentration in mole per dm, and the same time solubility is number of moles divided by volume. But can you remember that number of moles is mass over molar mass? So by solubility, which is C, is equals to, I will replace this N with mass over molar mass. That is mass over molar mass divided by volume. If I convert this division sign to multiplication sign, I would have C equals to mass over molar mass times 1 over V. And that brings us to the formula of solubility. The first formula, so this C, solubility, C equals mass times 1 over molar mass times volume A dmq. Now, why is it important for you to know how to derive this? It's important. I could have just come up and given you this formula, and I don't tell you how. So I have just shown you how we derive this formula, so that when you get to the exam hall, you don't get confused. All right. So this is the first one. If you are asked to find the solubility and the volume you were given is in dmq, then you make use of this formula. All right. And that aligns with our concentration in mole per dmq or solubility in mole per dmq. Alright? Because this mass over molar mass is actually number of moles. If the volume you were given is in cmq, then you remember that volume can be measured in centimeter cube, dmq, or liter. And what is the relationship? 1000 centimeter cube equals to 1 dmq equals to 1 liter. So that means if you were giving your volume in centimeter cube, you have to divide by 1000 to convert to dmq. So here, if the volume you were given is in centimeter cube, your solubility is simply going to be mass times 1000 over molar mass times volume in cm3. So this time around, our volume is in centimeter cube, and then the mass is being multiplied by 1000. How? Why? The reason is simple. The reason is because if you come back here, you remember that you said solubility, which is molar concentration, is N over V, and that is N divided by V. And this V is in dmq. Alright, so assuming I was giving my V in centimeter cube, trying to derive this equation now, trying to derive this for you. Assuming you were giving your V in cm cube, this will be V in cm cube divided by 1000. That's to convert it to dmq. If you have 50 cm cube, so all you need to do is 1000 cm cube equals to 1 dmq. Then 50 cm cube is x. When you cross multiply, you have 50, 1000x, so you eventually divide by 1000. So to convert from cm cube to dm cube, you divide by 1000. And that's what we have done here. So your n will now be what? N will be this division. If I change it to multiplication, that will be what? 1000 comes up over V in cm cube. And of course, you remember that your number of moles is mass over molar mass. So I'm going to have my mass over molar mass times this. So this is the second formula for solubility. So you can simply say solubility is equals to mass times 1000 over molar mass times volume in cm3. So as a means of reminder, the difference between the two is if the solute or the solvent we're giving or solution is in dmq, you don't need to include 1000. But if the solution you were giving is not in dmq, if it is centimeter cube, you need 1000. That's number one. Number, the third thing you need to notice, you could be giving the mass in grams. The question could say 50 grams of salt dissolved in 100 grams of water. The meaning of that 100 grams, just equate it to volume. So 100 grams is the same thing as 100 cm cube. 1000 grams is the same thing as 1000 cm cube, which is 1 dm cube. And that's where the third equation I gave you earlier, where you have the amount in grams present in 1000 grams. So that 1000 grams is equivalent to 1000 cm cube. or 1 DM cube. So I can simply say amount in grams present in 1000 grams, or amount in grams present in 1 DM cube, or amount in grams present in 1000 cl. 15.3 gram of sample of potassium triacylchlorate 5, so this potassium triacylchlorate 5 was required to make a saturated solution with 50 cl cube of water at 25 degrees Celsius. What is the solubility of the salt at 25 degrees Celsius? So you were given parameters. The mass is 15.3 grams, and of course the volume is 50 centimeter cube. Okay, you were given temperature, but anytime you are solving solubility, you don't make use of that temperature given. It is just a way to actually confuse a lot of students. It's a distraction. So you don't need that temperature, you don't need that parameter. And of course you were given, so potassium triacylchlorate, let's calculate the molar mass. Potassium is 39, chlorine is 35.5, oxygen is 3 times 16. So you have 39 plus 35.5 plus 48. That is the molar mass, 122.5. So the question is asking us to calculate the solubility of the salt, molar concentration, the mole per DM. So our solubility is going to be what? Mass. Since we were given our volume in cl, so times 1000 over molar mass times volume in cl, and the answer is going to be what? Our solubility will be, the mass is what? 15.3 times 1000 divided by the molar mass is 122.5 multiplied by the V, which is 50. 0 cancels 0. 5 here, this is 20. So 0, this moves here, so we have 153 times 2 divided by 122.5. So the answer is 2.5 mole per DM cube. That is the answer to the question. So you can confirm that from your calculator. The answer is going to be 2.5 mole per DM, and that is option A. Let us look at another example. What is the solubility of a substance A if 50 cl cube of saturated solution contains 8 grams of A? The molar mass of A is 60 grams per mole. So what are the parameters given? You were given the volume to be 50 cl cube, that is this, alright, and you were given the mass to be 8.0 gram, and you were given the molar mass to be 60 grams per mole. So because you were given the mass, you were given your volume in cl cube, we are going to make use of this formula. Solubility is equals to mass times 1000 over molar mass times volume in centimeter cube. So the solubility is going to be, the mass is what? 8 multiplied by 1000 divided by, the molar mass is what? 60 times, and the volume is 50 cl cube. Alright, so 2 zeros cancels 2 zeros, so you have 80 divided by 30. This cancels it. 3 in 8, that is 2 points, that is 6. In 20, 2.66, approximately 2.67 mole per DM cube. So the answer is going to be 2.67 mole per DM cube. And so with that, we have come to the end of this class. Just take note of the formula. Once you use it, it will solve any question that you come across. Thank you for being a part of this class. If you have not subscribed to our channel, do well to hit the subscribe button now and share this video with your friends. Remember to drop your comments in the comment section and hit the notification bell so that you could get notified once we drop a new content. Thank you. See you in the next class. Bye.